whatever. You can deal with it. A grocer, the guy that works at the Jewel, he sells 50 loaves of bread a day. The cost is 65 cents each. That's some cheap bread, ladies and gentlemen. Very, very, very cheap per loaf. That's very cheap bread.
I would buy it.
They estimate that for every 5 cents increase in price, 2 fewer loaves will be sold. What is the cost that will maximize profit? How many loaves are you going to sell? This is that style problem that you have cost and sales. Okay? This is your cost and sales problem. When you have something like that, you have this. We have some value in here and some value in here. What I want you to think about when you're talking about cost sales problems, at a cost of 65 cents, how many loaves of bread would you sell? 50. So at a cost of 65 cents, you sell 50. If I multiplied those two values together, it would tell me how much money I've made off of. Does that make sense? By multiplying those two values together, you're kind of distributing, you're fully to figure that out. Now, within that cost and that sales, they give you other information. It's stated that you had, for every 5 cent increase in price, 2 fewer loaves will be sold. Which means, for every time you have this 5 cents, if I multiply it by 1, it goes up a nickel. If I multiply it by 2, it goes up by a dime. If I multiply it by 3, it goes up by 15 cents, and so on and so on. If it goes up by a nickel here, I would sell 2 fewer. If it goes up by by a dime, I would sell 4 fewer, and so on. That's the balancing act of this. One price goes up. One part of it is the price is increasing, the sales is going to decrease. We need to find that happy medium that allows it to be your best break even point. Okay? So what you want to think of here is that these values, this 1, 2, 3, 4, 5, whatever, is that scalar multiplier of some value of x. How many times is being multiplied by that nickel? That same value is how many fewer you're going to sell. And that's what students have a hard time comprehending. What happens here is these numbers here are become the x, the multiplier. Bless you. So as the cost increases, so this becomes a plus sign, by a nickel times something, 2 fewer of that multiplier are sold. This now becomes our problem. What's nice about this style is that it is written in intercept form. As you guys might have noticed, intercept form is one of the fastest ways to graph things because you can get your zeros right away. Remember, intercept form is if we set both of these two, remember terms are what are in parentheses. If we set those terms equal to 0 to solve for x, we're going to figure out where it crosses the x-axis. We know that we have to find a maximum. It makes sense because if I multiply my two x values together, it gives me a negative value, which means it's a negative x squared, so the a value had to be negative. So it's down like a frown, much like most of your faces right now. You should be happy. That's the best fake smile all day. Good work. So, you set this equal to 0. And we're going to figure out where it crosses the axis. Add 2x, divide out, you get 25. You okay with that? Here it's going to be 0.65 divided by negative 0.05, which is negative 15, I think. 13, yes, 13. So it's negative 13. So the parabola is going to cross the x-axis.
You go up like a cup and you have to find a maximum.
What's down like a frown?
It sounds like a frown. What?
Right. It's down like a frown because it's maximum. Maximums are down like a frown.
Oh, that's what I meant to say.
What happens halfway between those two zeros? The axis of symmetry. And the vertex will lie on that. Because when you have zeros, these two guys are symmetric twins. Symmetric twins occur, they're always going to be equidistant from your axis of symmetry. That's what's nice about working with intercept form, is that you already have that, and it's very quick to find that halfway point. So all we have to do is figure out how far apart these two are. Well, negative 13 plus 25 is what? 12? And what's half of 12? 6. So 6 is the halfway point between the two. Does that make sense? So if 6 is the halfway point, that means that my x value is 6. My x value is 6, that means, well, that's the multiplier that I would use to figure out, well, if 6 is my multiplier for x, that means that if I take 0.65 plus 0.05 times 6, that's going to tell me my maximum selling. Yes, sir?
Where did you get the 6?
What's negative 13 plus 25?
Okay.
Is 12, and then half of 12 is 6.
Okay.
It's the mid. What we're doing is we're finding the midpoint between negative 13 and 25. 6 nickels is how much money?
33 cents.
What's 30 cents and 65 cents? It's 95 cents. The maximum selling price would be at 95 cents.
So easy when you do it up here with the number of
But what I'm trying to do here is, all I'm trying to do here though is I'm trying to show you guys that it is so much easier than what you give yourselves credit for. For some odd reason, the cost sales problem is the toughest for you guys always to work with. It always has been.
If it's set up in this exact way every single time, saying it sells for this much, and it will have something just decrease in this, then I just do it.
And basically they are set up the same way, but sometimes it could say if for every decrease in price, sales could increase. It just works the other way.
Yeah,
But
yeah.
in each and every one of these problems, this cost sales one, they all work the
But
same.
when it starts saying stuff like 1/3 of this is the same as something else, or then it's
I
like,
got you.
what?
So your maximum selling price is that, and for 50 minus 2 times 6 is going to give you the maximum number of loaves of bread to sell,
Every day.
apparently. So what's 50 minus 12?
38.
You will sell 38 loaves of bread. Oh, that's not it.
I think that they should just keep it.
Okay.
Wait, what's the vertex now?
We don't really need to worry about what the vertex value is.
So
Because
then
what,
if you want to find how much money you're going to make, you can start at 38, right?
yeah, and that's what the vertex would tell you.
Oh.
The number of loaves of bread would be 38. The price would be 95. The actual cost then of what you would get would be 95 cents times 38, which would be $3. The $38 subtract would be,
Let's see if you get that.
that's too much math, which is 38 nickels. $1.90, so it would be $36.10.
Yeah,
Yeah! Yay, math!
$36.10. Is that a
How
lot
are you
to
right?
pay in one day?
What's that?
How are you right?
Okay. 95 cents is pretty darn close to $1, right?
He's like so excited now. He's like,
Man! So 95 cents is close to $1. $1 times 38 is 38 bucks. Okay. There are how many nickels in $1? 20 of them. So there are 20 nickels in $1, so I took out 18 of them.
okay. Or you can just imagine time, like the time before that.
How about this? This one's for you. We getting better, a little better? Good. Go easy. Let's try home. Bless you. I don't know.
Since I'm like driving, I know road names now. But before, I didn't know. It could be like 4th Street and I'd be like, oh, weird. But now that I can drive, I know what 4th Street is. Because otherwise, I would probably get lost. Good one, Sawyer. What's the interstate called? Dude, people drive so stupid on the interstate. Dude, I was driving home from dance last night, and this car, like, I was not going slow.
Dude,
And he, like, completely cut me off. I thought he was gonna hit me. I was scared.
just, if you want to know how bad drivers really are, pull a 30-foot trailer going down the highway at 70 miles an hour and watch people cut in front of you all day long.
That's how I.
People are stupid.
I'm not fun. That would be scary.
A bus company transports 500 people a day between Morse Road and Highview Road. That's a lot of people between those two streets. The one-way fare is 50 cents. I'm guessing this is from an older text. The owner estimates for every dime price increase, 50 passengers will be lost. Not as in like they don't know where they're going. They probably just won't take the bus anymore. That was supposed to be kind of funny. Thanks, Trap. You're the best. What price will maximize their profit? You have cost and sales. All right, you have cost and sales. At 50 cents, how many people do you transport? 500. Are you noticing the relationship now between those first two values? If I multiply 50 cents times 500, I get my sales, my overall sales figure. How much am I getting? I'm getting $250. For every increase of a dime, I lose 50 passengers. That seems like a huge hit, to be honest with you. So I'm adding a dime here, and I'm taking away,
10 cents?
Increase the
Change
price
one
by
to
a-
50 people?
apparently,
If you increase the price by a whole dollar, you lose all your taxes.
yeah, it's crazy, isn't it? Those are my two values then. Again, the easiest way to set these things up is to find our midpoints here, our intercepts. 0.5 divided by negative 0.1 is, I think it's negative 5, right? And then if I take 50 divided by 500 divided by 50, is it 10?
Yeah.
Okay. So what's negative 5 and 10? What's half of 5? How did I get, which one? The negative 5? Is that what you're asking? I got the negative 5? These two are, when you have intercept form, all you're doing is just taking each part and setting equal to 0, solve for x. Subtract this, divide it out, so you get 5, negative 5. That's all. You can use a calculator if you want. So now that means that, excuse me, if I increase it 2.5 times, that's going to be my maximize out. So if we take this 2.5 time, if I take 0.5 plus 1 times 2.5. What does that give? What's that?
Let's guess.
I know what it's going to be.
Wait, how do you know?
75 cents.
1.25.
What is it?
1.25. Oh, it's plus, not multiplied.
Yes, sir. Figure out what that equals.
75 cents is,
Right.
that becomes 0.25, 0.25.
Because remember the decimal just moves over to here then? 50 cents and 25 cents is 75 cents.
It would be the same as dividing by 10.
Oh, okay.
So if I charge 75 cents, that would be my maximum amount.
You have 375 chapters left.
Seems like a lot of people don't use.
It does. It must be a very busy street or route. I don't know. Maybe it's going from a train station to a parking garage. I don't know.
Well, then wouldn't you think that even though there's a 10-cent increase, that people would be like, oh, well, I still need to take it?
Apparently.
Not.
And to be honest with you, stuff like this, is a very, very common business applications. These types of problems really, they show up all the time. Hannah Oberg was telling me that her brother Caleb was working, he's taking business calc right now over at NIU, and which I think is calc, it's like 220 or, yeah, it's 220. And he was saying, he told her to tell me that he's doing these same style of problems right now because this is what you start with. Quadratic word problems are very, very common for a business application. Okay? They're very, very common. One of the things that you guys hopefully saw that on the website, let me see if I can get this. Let's do this a little easier. I want to show you guys where I put a couple of the word problems. I emailed you guys the links, but I also want to show you where I put them on the website so you can find them. If you just click Algebra 2, that's where it showed up with the syllabus, the websites, the homework sheets that I still don't use. You should probably start emailing them. But I put in here quadratic word problems, 2 tabs. Let me show you what some of these are. I'm a teacher. I find things on the internet and I hyperlink it. It's great. So, as you read through some of these things here, tickets to a school dance cost $4 and the projected attendance is 300 people. For every 10-cent increase in price, the dance committee projects that attendance will decrease by 5. Determine the dance committee's greatest possible revenue. What ticket price will produce the greatest revenue? Take a second and try that.
Wouldn't A and B have
Wait, so are we turning it on?
No, I just put up all the answers. I hope that you had no problem with those. Those were really easy.
I didn't have a
Wouldn't
problem
you-
from the alt.
wouldn't you
But it looks so neat. Why does he not?
Either one. Yes, sir. Yeah, I was just realizing that that's not a very good picture here. Hey, what?
Since the formula is like x minus, does that mean that if for the two answers we
Oh.
get like? Oh, if it's plus and minus, and then like when you get the answers, if like one of them is like negative 40, wouldn't it be like? Oh wait a second. Oh.
All right, see how we did.
Like, wouldn't it be like negative? Like if it's positive?
Yeah, your zero. If the term is positive, the zero will be negative.
Yeah.
If the term is negative, the answer will be positive. SMRT.
Yeah.
It's funny because when we see something on the main page, it says that.
Is that where I got that from?
Yeah, that's home Simpson.
Well, like it's not the
Cost and sales, guys. Your cost is $4, and you're going to sell 300. If you increase 10 cents for your dance ticket, you're going to lose 5 people. Good riddance. Sayonara.
It's actually like, it actually seems more realistic.
So now get our zeros. We're going to have zeros then at, let's see, 4 to be what, negative 40?
Yeah.
So we have a 0 at negative 40, and the other one is at 60.
Add those together, divide by 2,
Okay.
get the AOS is 10.
Okay, I got
10.
it right.
Axis of symmetry is at 10.
Plug those in, you get price is $5 and 10 Ds is $250.
Perfect.
I got.
See how that works, guys? Once you get that axis of symmetry, that tells you that's going to be your x value that is going to give you your best cost. It's going to tell you how many people you're going to lose. Yes, sir.
Total revenue is $1,250.
And then when you put them together, that gives you your total revenue. So what happens here is that if we charge $5, we're going to have a total then of 250 people.
This isn't really very realistic because school dances, they just want to get all the kids.
I'm with you, but there's only so many types of word problems like this that I can find. Beggars can't be choosers.
I would actually prefer this kind of price compared to what they charge for homecoming prom.
Well, we could have added a 0 and moved it from $40 to $10 increase and then made it 3,000 people and 50. I mean, you can play with the numbers and still get the same scenarios. So what I want you guys to try and work on this tonight
Middle school, that was like $3 or $4.
Yeah, make sure it's
is if you go through back on the website here, this one was the first group. Let's see, the second group was the second group of these word problems are so much of them that are straight calculator. Move your cursor, try to find the maximum, try to find the minimum stuff. The first part, let me write this on here. This first one, I'll use this one. This one has and this one has the so what I would want you guys to look at this evening is on the worksheet I was just showing you here, this more quad problems where it says the cost sales. If we go back here, there's only, let's see, there's Oh, actually, I did have the modeling ones on here too. 1, 2, we did 3. Quadratic equation. Actually, it's not a cost sales one. I think there's like 6 word problems in this one. Let's do this one. I'm going to highlight this one for tonight. I'm going to change this one. So yeah. Okay. We'll do these for today. And if I look at it, it starts on the 4th page. So there's 1, 2, we did that one, 3, 4, 5, 6. There are 6 problems, okay? Each one of them is extremely similar to ones we've already done. The stained glass window, the mural where you're taking less material off, okay, and the rocket ship one, okay? So go ahead and start on those. It like I said, I'm trying to think of a better way to bolt this out.
Is there test tomorrow or Thursday?
It's still Thursday. We'll still go Thursday because I wanted to make sure I had a day of a little bit more time to look at some more of the word problems today and then a little bit tomorrow before we start doing all the other, like solve the equations and completing the squares, stuff like that, because that stuff's a little bit easier to go through than it is to give you guys more time to ask questions about word problems. Okay, so work on these. There's those 6 of them on this part here. If you want to get ahead and start looking at some of these other word problems that are on the second part, by all means, open that up as well. Those problems are like on the second. I think it gets out to about the 6th page or so. These problems are again quite literally y equals problems. Goes right to your table and you're searching for values. So if you want to practice that, go for it. I think there might even be answers for these at the very end. Nope, not on these. So, but yeah, I'd look through a couple of these things too. Bring them into Flex if there's something question or if you want to check and see how you did it, I can show you. These are really easy. That's just how autocalculator works, okay? What's up? It's the one that's right below that tab there.
So we don't like have homework, it's just.
No, I want you to do those 6 word problems. It's do these for homework.
Oh.
Yeah, that's kind of easy to go.
Just all of them are on
Yeah, yes, ma'am. And I'll put it on the calendar with a link to that page also.
yes.
So if you guys look at the calendar now, if you can't find out which ones to do, on the calendar itself, if you click on the tab, the website's right there. Just copy and paste it, okay? If I click more details, I should be able to link it right from there. Does that make sense? Boy, the internet makes this easy to send you stuff to do. Get out. Yeah, it is. Did you look at the calendar? Keep scrolling. Remember I said it starts about on the 3rd page, 4th page of that? There you go. You just pass. It starts with the rocket ship.